So the question is, the D string of a violin, so we're talking about a string, is 32.5 centimeters. So that's length equals 32.5 centimeters. And it weighs 0.37 grams. So its mass is 0.37 grams. The wave in the string travels at 200 meters per second, so that's velocity. What is the tension of the string? So we have to figure out, we have length, mass, velocity, and tension. Do we have a formula that includes all of that? Sort of, but not quite. So velocity in a string equals the square root of t over mu. We have velocity. We're solving for tension, but we don't quite have mu yet. All right, and it turns out we said earlier mu is equal to mass over length. Now we have to convert 32.5 centimeters. We need to convert to meters. So that equals 0.325 meters. And we have to convert this to kilograms. So there are 1,000 grams in 1 kilogram. And 1,000 is 10 to the minus third. So I'm going to make this, so we don't have a million decimal points, 0.37 times 10 to the minus third kilograms. So now we can put in 0.37 times 10 to the minus third divided by 0.325. This is kilograms, and this is meters. And if we do the math, that turns out to be 1.14 kilograms per meter. So now we have mu, and we're solving for t. So in order to get t, we have to square both sides since t is in the square root sign. So squaring both sides, we get v squared equals t over mu. And we want to isolate t, so we can take mu and bring it to the other side. So we get t equals v squared times mu. Now we're ready to plug in. V is 200. Mu is 1.14 kilograms per meter. So we get 200 squared times 1.14 kilograms per meter. 200 squared, 200 is 2 times 10 to the second. So squaring it gives us 4 times 10 to the fourth. That's 10 to the minus third times 1.14 times 10 to the minus third. 10 to the fourth times 10 to the minus third is 10. So that gives us over here 4 times 1.14 times 10. And when you plug that all into a calculator, that gives you 45.6 newtons. And if you remember, a newton is about 1/4 of a pound. So that means that's about 12 pounds of tension. The answer is 45.6. We know that it's about 12 pounds, And that seems like a reasonable amount of tension for a violin string. We don't think that a violin string is going to snap with 12 pounds of tension.